Hi, my name is Nathan Alexander, and I'm about to elaborate on an experiment that I have done, or I'm about to show you, and it's to test centripetal force. And this is my circuit that I've set up to, to experiment on centripetal force. Now, before we begin, centripetal force, you may be asking yourself, what is centripetal force? This is the force that allows an object to continuously rotate around in a circle. Take, for instance, the Earth rotating around the Sun. What causes the Earth to rotate around the Sun is a gravitational pull from the Sun itself, right? But in the case of this experiment, or this apparatus that I've set up here, the force that will cause this nut to rotate around in a circle by a motor is this string attached here, and the force experienced here will be tension, and this will be the centripetal force causing it to rotate around. And centripetal force, the magnitude of it could be increased or decreased depending on three different factors. These factors are the radius about which the object rotates at, the mass of the object, and the velocity or speed at which the object is rotating at. And we know that, well, in physics we are taught that an object rotating around a circle is accelerating towards the circle, the center of the circle. But in this experiment we are going to find the magnitude of that centripetal force due to change in mass, change in radius, and change in velocity. In this case, I'll change the velocity at which the object rotates at by these three different sources. These will vary the amount of current flowing through the circuit, and that will ultimately change or decrease the velocity. So I have three different sources here. These two are a combination of this. So this is 1.5, 1.5. So together they'll be 3 volts. And these two are also 1.5, but this supplies more current than this one. So I have my source and I have my switch to operate the motor, turning it on and off. This is the motor here between these two blocks of wood, and I have my tire attached here to help me initiate the circular motion. And what I did here, come on this side, right? I attached a piece of paper here, so as the object rotates, you'll hear every time it makes a complete revolution. And also, to find the accurate radius about which the circle rotates at, I put this ruler here, right, by which I could start from the outermost part of the ruler, and work my way in until I could find the exact radius about which the object rotates. Well, that's enough of explanation. Let's see it work. So I'm going to initiate it and start by switching it on. As you could see, it's making complete revolutions, and every revolution is hitting the paper. So you could count how many revolutions it's making. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But we'll record the time for 20 oscillations, and that will be the period about which the object rotates. Now I could demonstrate by showing exactly at what radius it's rotating at. Now I have to work my way in slowly so I won't damage my ruler. And there it hits. And that will be approximately 19 centimeters. Right there. Okay, I'm switching off the circuit. and I'm going to change the velocity of the circuit, and I'll exaggerate it by going to the smallest battery here, connect both ends, and then I'll reinitiate it and start my revolutions using the switch. Now you see how slowly it rotates, and it will take time to build up to its maximum velocity. And as you can see again, every time it hits the paper, this signifies that a complete revolution is made. Right? And that's basically it. Thank you very much.